So we're a practice in London, and for the last 20 years or so, we've been thinking about and researching and drawing and making and building timber buildings. And I'm going to talk to you this morning about a project which actually we finished on Friday in Shoreditch. It's an office building called the Black and White Building for the office group, and the engineers here. Hi. Just finished on Friday, and it's a co-working office building, and it's constructed entirely of timber from the basement up. So timber columns, beams, floor slabs, lift core, staircases, curtain walling is timber, and the external solar shading is timber. We use an LVL frame. So LVL is like a jumbo plywood. So a veneer rather than a plank timber, which is incredibly strong, about 3 times stronger than concrete. And if you imagine the buildings that we build, the timber buildings are very lightweight. So this building weighs about 1/3 of what an equivalent kind of concrete frame building would weigh. So the issue we always have is not holding the building up, but it's the shear forces on the building. So with a building like this, we use the LVL to take all the gravitational load, and then rather than sitting the floor slabs on top of the beams like this, we sit the floor slabs within the structure. So then we lock the structure tight. And in that way, we can use less timber. So on this project, we use about 40% less timber than we used on our first office building. So for us, one of our kind of primary themes is not only in demonstrating that timber is a viable alternative to concrete and steel, but also thinking about how we can use as little of the material as possible. So you can see in our plan and section that the building is optimized for timber use. So the position of the core, the position of the structure is all about optimizing timber. So it's all about designing the building from the inside out. And this is a very simple building. This is made from 872 pieces of timber, each one of which arrives by truck at the front of the site, has a QR code on the timber. One of the people on site reads the QR code off, and it reconstructs the digital twin model on site on an iPad. Everything carefully, excellently put into place. In fact, you can see here the groove at the top there, where the floor slab sits into the structure. So on the outside of the building, we have a tulip wood, an American hardwood, which has been thermally modified, which acts as a solar shade in order that we can have completely clear glazing in the building. And by having clear glazing, we have glass that can be recycled, but also that you can enjoy the kind of health and well-being benefits of being in a timber building and seeing natural light coming into that space. And you can see here, very simple system of connecting the building, joining the building, and all the connections are built within the timber. So the timber structure itself fireproofs all the steel connection details. So you can see here the frame going up. This is the LVL frame here, and the CLT plates going into it. And you can see the whole building was just built off the pavement here. So just as the trucks arrived in, they're craned, the pieces are craned into position on the site. And we built 4,500 square meters in 13 weeks. So in order to design the exterior of the building, we put a model of the building within a solar path diagram to measure the solar gain against the facade. And looking at the solar gain on the facade, then designed a series of louvers in order to be able to mitigate that solar gain on the facade. And these louvers vary in depth and in frequency depending on how much sun hits the facade at that point. So you can see here, this is the solar shading on the northwest facade. And as I said, this is using an American tulip wood, which is an unfortunate tree. It's a very beautiful timber, but it has a very small root bowl. And so as climate change has happened and the winds have got faster in the States, these trees have largely blown over. So we've been able to use this resource in this building here. So you can see everything is put together in a very kind of simple fashion. So everything is screwed and not glued, so the building is able to be demounted as easily as it was implemented. And this is the beginning of the internal spaces. You can see just how quite strong this material is, because we're able to haunch up here to allow the services to pass through across the slab. So the entire timber structure is exposed. And so when you're inside the spaces, you really have a clear understanding of how the whole building is put together. And this isn't an ostentatious building. This is a very simple structure. This is a structure that is immediately legible when you walk in the building. I think you have a clear understanding of the intent of this building, that this is a simple, useful, natural space where the natural materials, the natural daylight are the things that really shine out. And carbon accounting is something that we take very seriously, not only after the job's done, but also during the design process. So design decisions that we take during the design process, we're measuring as we go. And you can see here, this is our basement, and this is the rest of the building. The basement, in fact, we're just finishing off the final life cycle analysis at the moment. The basement represents about 40% of the whole life carbon. But the building itself is about 20% below all the 2030 targets for carbon emissions in buildings, embodied carbon in buildings. So this is the entrance to the building here, down here, through there. And that's the number of tree seeds that it took to grow the trees that built the building. Thank you.